Hey, QED coders, this is Michael. Jan's not going to be joining us today, and I was hoping that I would be able to show you the Jinaga MCP working, but we have one more thing that we need to get finished on it, and maybe I'll show you how that progress is going because I've got this machine right here doing that work. Um, but today, instead, I think I would like to show you how the wireframes that we talked about last week have progressed. And this is pretty exciting because I think this is a process that we can all employ and mix into our software factories. Um, and it really works exceptionally well with a Jinaga application. So um, let's first start by checking in with the laptop. Um, so it is working on a problem where it's not reading from the replicator in order to return results of a specification. And so what it's doing right now is setting up the Docker Compose stack that I've been developing on up until the point that I released Azure, and it's checking to see if it can reproduce in the Docker Compose stack. Um, and it looks like it's ruled out a hypothesis. Very good. Okay. Yeah, I've told this thing to think like a scientist, create hypotheses, experiments. Um, that really produces excellent results. Um, so yeah, can distribute to all. Yes. So it's got the distribution rule set up. So very curious why this isn't working. But while this is going, let's flip on over to wireframes. So this is my reMarkable, and I use this for my daily note-taking, task tracking. This is my system, my trusted system. And so I've integrated my projects into the reMarkable so that I can sit down and read a specification. And I can page through it and make make edits just by writing on the reMarkable. The latest type of specification that that I've got synced to the reMarkable is the annotated wireframes. Now, we talked about annotated wireframes last week, and how I introduced the annotated wireframes from chapter 4 of the book. Might be chapter 4, might be chapter 5. I introduced them into my process, and then the agent started to create ASCII art wireframes, which solved the problem, but could be better. I was mostly concerned with token use. So to generate ASCII art as opposed to generate a short description, it's it's much fewer tokens for the short description, and then of course the jagged right edge problem because an LLM doesn't know how many characters are in a token. It's just not a thing that's important in the training set. And so what I've installed here is an open source project. You'll find it on GitHub. It is called Wireloom. Wireloom. So as in wireframes, but it is a way to specify wireframes in the same way that you would specify a mermaid diagram. There is another more popular library. For some reason, I can't remember the name of it right now, but this one supports annotations, and it is really high fidelity. So I decided this was the one that I wanted to use. Annotations are very important to my process. So yeah, you can see I've got these callouts with these numbers, and these numbers can be cross-referenced with this information in the document. So this right here is the um, the uh, uh, the page that somebody would land on if they were a brand new user, or not a brand new user, but a returning user to the factual MCP. So they can come in here, see the invitations that they have created. This is for an admin, and they can create new invitations. And yeah, this was a feature that I realized after deploying it that was not in there. I need to be able to get a workspace for myself. So it either had um, the admin UI, or it had the non-admin UI who could accept invitations. So I was like, no, let's navigate over to there. So you can see here I've got a call out that I have handwritten. When I take a look at the generated application, this this thing still looks open. So I'm basically reporting a bug on the wireframes. It's not a review of the wireframes themselves. Now the wireframe says this should be this should have the note right here. That's what 25 indicates. This is the note. But I was looking at this this document and doing my my testing, comparing the document to the running app. Noticed the bug, and so I jotted it down. So some of these others are annotations more directly related to the application itself. So if I come back to this one here, now I've got, hey, I don't have a back button right here. So now this is a wireframe annotation. I want to change the wireframes, and so I've made a note about how to change the wireframes. And so already this is a really useful part of the process. It integrates well with generating designs and validating those designs, and then sharing those in a way that is easily reviewable. So already I love this. But then there's one more thing that I can do, and that I can ask the agent to load in this information from my reMarkable, and then it will be able to see this annotation, not to be confused with these annotations. It will be able to see this handwriting, read it. It can actually read my handwriting, and then we can iterate on how to resolve that particular note. So I'm going to try to demonstrate that that capability. Hopefully, that's going to demo well. But before I do, I also want to show how these annotated wireframes in this document correspond with the underlying model, and how the this design system, not to be confused with the visual design system, how this system of designing applications is cohesive, how everything holds together. And so if we come all the way back to the beginning, we will see, yeah, here's a simplified model, but this isn't the full model. It's got a note in here that this is supposed to be combined with the full model at signup model at MD. And this is just the redeemers slice. Actually, that's not true. This also contains admin, but nevertheless, we are talking about a subset of the model makes it into sort of the sitemap of this application. So what is this sign up model thing? Well, if I go back to designs, then in here I've got my sign up model. So let me go all the way back to whoop, all the way back to page 1. So this is the model expressed in the factual language. And so in order to generate this, I showed it chapter, what is it, 2? Chapter 3? I think chapter 3 of the book is where I talk about how to read a factual model, a historical model. And so in that chapter, I lay out the visual language and the textual language. So it has examples of the graphs as well as the factual, the factual text. And so, keeps spilling coffee on my keyboard. What's up with that? This right here is the full model at a glance. So let's walk through this because we've seen on this channel several different models for different applications, and we just so happen to be using this application in order to get people signed up for using the Jinaga MCP. So everything starts with the Jinaga user. That one is a built-in fact type, and it can represent somebody who's logged in. It can represent a service account for some kind of service that's running in the background. It can represent a single-use user. There's lots of things that could be a user. It's a user principal. It's something that has a key pair that establishes its identity, and something that can be the basis for authentication and authorization. So that's a Jinaga user. We're using that in several different ways. So the first way here, the domain. So this is using the enterprise domain pattern, which we use a single use user in order to create the domain and to create the first admin for that domain. So that's this fact over here. And then we throw away that private key so that we cannot mint any more facts for that particular domain. The administrator now has the authorization to invite new administrators, to create invitations, etc. So that one-time pass has set up the administrator. The reason that I don't want the administrator to be the predecessor is that we can revoke administrator access, and this administrator can assign administrator permissions to another person. And so if I needed to transfer my domain to somebody else, I don't want to be stuck here at the predecessor where I could never be revoked. So that allows me to create a new administrator, then they can revoke me, and it belongs to them. So that is that administrator and domain setup. And now, once I've got an administrator, I can create invitations. So I go to the website, I say, I want to create a new invitation. It generates an invitation code. And notice the invitation code is a top-level fact type in and of itself. The only thing inside of the invitation code is the code itself. So if you type in the code, you're referencing that fact. That's going to be very important when I then share that invitation with somebody else. And then I've got the workspace request, where I come along as a different kind of user, a different user entirely, and I say, this domain, I would like to request a workspace. Well, at the moment, I am not. There's no credential. There's no. There's nothing that that tells me that this workspace request should be granted. So things that that could fill that role is if I have entered my credit card and signed up for an annual plan. Now I can create a workspace and use that plan. Or if I have received an invitation. So I'll create an invitation redemption that says I'm redeeming this invitation in order to establish this workspace request. So that user comes along, creates these two facts after they've signed in, and now they've got a workspace request. Meanwhile, in the background, there is a service that is looking for these workspace requests, and when it finds one, then it runs a whole bunch of checks. It checks to see if there's an invitation redemption as a successor to the workspace request, and then if the invitation for that invitation redemption has no other invitation redemptions, single use. And so if it validates that, and then it also validates things like the expiry date of the invitation, it looks to see if the invitation revoked exists. So if this invitation has been revoked, it checks all those things. So all of those things are checks that cannot be performed in model itself. This is pretty important. In fact, I think I will bring up, excuse me, the code for for this background so that we can see that in action. But but things that can be enforced in model are things like these predecessor relationships. The fact that it was this user that created this workspace request, and and then I could see by the signature that it was indeed that user that created it, and I can run authorization rules in order to make sure that they are indeed authorized to do so. So some things can be done in model, but you cannot in model guarantee that there's only one successor. So there is nothing in the model that guarantees that we don't try to create another invitation redemption for this invitation. We can create that. Nothing's going to prevent that. Then it's the background worker that is looking for these shapes, and then saying that, yep, only one redemption actually exists. And so that does bring up a race condition. If I had two workers in the background, then I could create two invitation redemptions simultaneously. They might each pick them up and not see the other one yet, and both create the workspace. Yeah, that's the outcome here, is it'll create a workspace successor. Another outcome is that it will create a workspace denied successor. So that race condition does exist. Here's the truth of the matter: that race condition always existed. In distributed systems, that is that kind of race condition is something then that you would have to centralize in order to resolve. You can centralize by literally creating a central data store, or by creating a consensus algorithm, which basically turns several different nodes into effectively a central data store, because they need to communicate more than the strong eventual consistency settling would require. It's not just that things have to settle; it's also that things have to they have to reach consensus, have to run a consensus algorithm. So without a consensus algorithm, without a proof of work, without a central database, those are different ways that you could solve the single-use problem. That race condition would exist. So this just makes it explicit. It says, hey, that's a real thing. So you have to design around it. All of those things, by the way, are very costly in terms of your runtime performance, your extra extra bandwidth, and so by default, historical modeling goes with the less costly options that then make it very apparent to you that this is the thing you need to look out for. And so the way that I have chosen to resolve this is, even if I do decide to scale up the background worker, in this case, since redeeming an invitation is a very infrequent thing. I might not decide to do that, but if I do, then this shape of multiple invitations, redemptions for an invitation, where the workspace has been created, that shape now becomes visible. And I can have something that is looking for that shape and then reporting on it. So I can see after the fact if a race condition has occurred. And then I can mitigate it. So it may never happen, but if it does, I want to know about it. And I want a path for mitigation. And so that mitigation is basically, as an administrator, I can see the note. I can talk to whoever it was that I sent this invitation to, and say, nope, you're only supposed to have one workspace, or you're not supposed to share that code, or whatever conversation we might have, which may, in this case, just be, well, you've got an extra workspace. Enjoy. But nevertheless, this process leads to a workspace or workspace denied, and now this user can begin using the MCP. So there's a little bit more happening here with owner. So we can see that the owner of a workspace is a user. And so that user is usually this this person right here that created the workspace request. But what if I wanted to transfer ownership? It's the same pattern as this. I should be able to create a new owner, and then they could take over that workspace even though they weren't the person that initially created it. So this is kind of like in when you're building an iOS application and you submit it to the Apple Store, and it's like, oh, you have to sign in with your developer account. Okay, here's the app. It's up on the store under that developer account. Hey, you know what? I actually built this for a client. Now I want to transfer it over to them. Oh, yeah. So this takes care of that. You build a workspace for these kinds of applications, and then you can transfer them to your clients or make them co-owners. Here, this service, this is the ability for a background service to operate on behalf of that workspace, which we will talk about in a later conversation. But that is the model at a glance. If we continue through here, we've got the details of the model. This is what these facts actually look like. Like, for example, Jinaga Cloud invitation code just has the code, no predecessors. So if you enter that same code, you're back to the same invitation, and you can run queries from there. So here's the full model spelled out. And now, speaking of running those queries, here's the specification to get the invitation by code. So you create that invitation code by typing it in, and then you look for the invitation where that code's predecessor, or code's predecessor is that invitation code. And now you can get the hash of the invitation, and you can get the expiration, and you can do things with that. Invitation revoked by code. And then here from the book, kind of diagram what the specification does. So these dark arrows are predecessors. So you've got your invitation code. The invitation is a successor. Invitation revoked, a successor of that. And then these two specifications search down the graph. So kind of spell that out. So the document goes into a bit more detail about the other specifications that are important to execute this process. So the process that I just went through just narratively before, this is a more precise description of that narration. And so this goes through all of the specifications that you need in order to accomplish the result, shows diagrams to make them a little bit more apparent. and so those are the things that are necessary for a user of various types to get information. Now, when they act, when they create new information, then they execute an action. So here, create a domain. We are going to create a user for the administrator's public key, and then using a single-use user, we'll create the domain and the administrator fact. So this is inside of these brackets, the private key exists and is used to sign these facts. Once you leave the this scope, that private key is just discarded. And so these are the only facts that this single-use user will ever create. It'll create the domain and it'll create the first administrator. And then here, an administrator can issue an invitation. So here's your code. Let's create the invitation code and the invitation. We can revoke one. We can annotate the invitation by creating a note. And then when we send it over to the redeemer redeems that invitation by taking that request ID for that domain and the code, and they create a workspace request. So this is a random request ID. They type in that invitation code, so they create that invitation code fact, and then create the invitation redemption, linking those two together. Now here's the background worker that is doing that work that I just described. So it runs those specifications to figure out the shapes, to figure out if this invitation has been redeemed before and all that stuff. And then it will decide to either mint the workspace or deny the workspace. So it'll run one of these two actions. So all of these are baked into the Jinaga language. We've basically taken the narrative, the user stories, the use cases, and we've baked them into Jinaga. This shows a worked example. So what would it look like for an administrator to create a brand new domain and then issue an invitation? So this is just walking through. These are actual facts of those various types and walking through an example of those various facts. So the administrator creates the domain. There should be a single-use principal predecessor here. It forgot that detail. Then creates an invitation pointing back to an invitation code. The receiver of that creates the workspace request. So they log in as this Jinaga user, Bob, and then using that code, they find the invitation and then create the invitation redemption. So they've created that shape. And now the background worker is looking for these requests and decides, yes, that shape is good. There are no other invitation redemptions for this invitation. So I will create a workspace and I will make Bob the owner. And then when we need to access that workspace from the MCP, then we will set that up as a service. Okay, so that is how we have specified in factual, in a declarative language for the shape of the model, for the specifications, for the actions that the user can perform, and it is verifiable. You can check all of those relationships, and then when comparing that with the wireframe, what the model does, what the LLM does, now the agent, is that it verifies that every single fact type in that model is somehow represented in the user interface. There needs to be a way for the user to see that fact type. There needs to be a way for the user to create that fact type. And if there's any fact type that is not represented in the wireframes, then it calls out specifically why. So this makes sure that the application is complete. It's a full description. All of the features are exposed. So these two things need to work together in order to make sure that we build a complete application. Cool. Let's check in real quick on what is happening on this little machine right over here. So it has disproven one of its theories. Oh, that's awesome. Working through those hypotheses and rejecting them. Let's settle this empirically. Love it. So verify that the content type graph actual value matches what the server declares. Okay. So the thing that it's fighting, let me see if I can bring up the should be able to bring up, yep, there it is running on Azure. Okay, if I go back up to Jinaga.js, let's take a look at some issues. So because it started fighting this, I said we need to create an issue for this and we need to resolve it. But let's see if we can get past this before we actually do that work. This right here, distribution diagnostics. So in order to make sure that I've solved a race condition, I needed to have the not authorized to run this query. I needed that to look like it was just returning an empty set. The race condition was that I start up my application and I say, I am this kind of user. Like this happened in LaunchKinks. So I start up the voting application, the attendee application, and you say, I am an attendee. And that creates a fact, an attendee fact. Attendees are allowed to see the current state of the event. And so it creates that fact and then subscribes, show me the current state of the event. So if the subscription got to the replicator before the fact, then the replicator would say, well, you're not an attendee, I can't show you this. And it would give back a 403. But now the subscription is broken. The fact is going to arrive milliseconds later, and there was nothing to say, oh, that's just a temporary thing, retry that subscription. Actually, that was the workaround that it put into the application itself. Just retry that subscription on failure. Terrible, terrible workaround. I certainly don't want my application developers to have to do that kind of thing. So I made the replicator return an empty set. So, hey, the current state, I don't have any information for you until the attendee fact arrived. That fact closed the gap and authorized that particular subscription, and then at that point it was able to push the results back to the user. And so race condition yields the same thing in down either path. So it means it's no longer a race condition. So what that gives up, though, is 403 carries diagnostic information. It describes why you're not authorized. So this is this is an issue that is intended to resolve that. So we should be able to give back this extra information. So there are no authorization, no rules that apply to this feed. That one's never going to resolve. So go ahead and send back an error. If it's more restrictive, no authorization rules apply to this feed, or distribution rules apply to this feed. But in this case, we can actually give a little bit more information. So it actually will look for that specific case. It's like, oh, you're close, but you need to add this extra condition, and then it will match. This one right here is the only one that's the race condition. So yeah, here if if you're not authenticated, denied. But yeah, right here, if you're not authorized yet, but something might occur that where you could be, this is the only one where we give back that that empty set. And so so yeah, this is the plan to get that into place, and it's a multi-step plan across different different repositories. We've got some in Jinaga.js, and we've got some in Jinaga Server. And so I haven't executed on this plan yet, but because I don't have this in place, this agent is trying to figure out why it's getting empty results. It says, well, I know the empty results could mean not authorized, so there's no distribution rule. So it's got to do a lot of logging and splunking in order to figure out whether that is the case. So hopefully we'll get that resolved. But it's working on it. It's working on it. In the meantime, okay. In the meantime, what I would like to do is walk through this wireframe right here and see if we can pull in this note. Oh yeah, this is another runtime bug. It's like, oh, okay, this doesn't look like a clickable row. So we've got a couple of bug reports, a design change. So let's see if we can get that going. I don't remember if I set up the reMarkable API on this machine. So let's clear. All right, I was using Fable to do some stuff. Let me switch back to, yeah, okay, I am back to Sonnet. Yeah. Yeah, by the way, using the factual MCP should not require Opus or Fable. Should be usable completely at the Sonnet level. I'm even trying to optimize it for Haiku. Hopefully I'll even be able to get to offline models. So let's work our way down toward that. But right now it works well with Sonnet. And so I've been practicing with Sonnet as my default rather than Opus. So here I am with Sonnet. Oh yes, what I want to do is can you access my reMarkable documents? Let's see if I actually did set it up on this machine. Yeah. Yeah, by the way, I do have extra usage turned on because I was using Fable this morning and it burns through those tokens. Okay, don't have access to the reMarkable documents. Here's what I would, let me do this. I know that this machine does have that access already set up, so I'm going to come over here. And I'm going to start another one. That's Sonnet. Okay, so we've got another session. So this session is going to keep going, but I should be able to monitor a new session. Okay. Well, how do I... Well, let me go ahead and relaunch just to make sure. Remote control is active, so I should be able to see that via remote control over here, and then we can use that new session in order to fetch the annotations, the changes on my reMarkable, which is really fun. Are you updating? Here we go, Claude. Okay. Nope. Let's try it later. Okay. Now we are, yep, blank session. This session is inside of Factual MCP. So what I should be able to do is I'll just say fetch the sign up web UI. I'm curious why it's showing up like that. I intended for it to just be the document. Let's see, docs. Okay. Yeah. I guess when you're not actually on the machine, you can't just navigate the file system. Anyway, sign up, wireframe. I'll call it sign up UI wireframe document from my reMarkable. So we'll just start there. And then this has the reMarkable API installed, which is an open source API, the reMarkable CLI, RMCLI, is an open source CLI that accesses the reMarkable API. And allow clue. So here's RMAPI, so it's checking the version. So let's always allow that. It's currently in accept edit, so we're going to see all of these tool calls. I'll switch it to auto mode in just a little bit, but right now I do want to see the tool calls. It says that it's not authenticated to the reMarkable cloud yet. Okay, so yeah, maybe my token has expired. All right, hopefully we'll be able to get this set up real quick so I can show you this, because this is a pretty cool way to interact with the software. Okay, to authenticate RMAPI with reMarkable Cloud, you go here, you get an 8-character one-time code. Okay, we can do that. So we've got this going on here. So I'm going to go to that site. Here's my reMarkable. I'm going to log in, but I will do that over here because I don't want everybody being able to access my reMarkable. So yeah, we need to do the multi-factor and the CAPTCHA. I mean, yeah. Let's see, reset password. Yeah, this No, it thinks I forgot my password. And I'm trying to reset, or I'm trying to run. Okay. There we go. Gotta accept all cookies. Then we get a code. And so for this, the code's going to be visible. So I'm going to paste it in, submit it, and we will get this thing authenticated. Oh, it is a one-time device code, so maybe we're going to be okay. All right, so authenticating, found it, downloading. All right, so the one-time code has been used, so I don't mind too much showing it to you now. So here we are. So downloading the sign up web UI document from reMarkable. So it is going to run RMapi to get that document. Let's allow that. And then Cloud Code is going to inspect the contents of that download bundle. Now this is the moment where I switch to auto mode, and now we can let it go through all those different steps. But yep, so it has gone up to reMarkable Cloud. It's found that document, downloaded it to a temporary folder, and then it is looking at the handwritten annotations. So on 4 pages. So it's going to extract them and use the annotation extraction skill. So now this is where it's reading my handwriting. It's reading the arrows and the underlines and the crossouts and all of the interaction with the document underneath the annotations. So it's able to see the original document and the annotations and understand how they interact with one another. So to do that, it creates a composite PNG so that it can then look at those pages. Otherwise, it's just looking at the raw PNG with no annotations and then a bunch of points. So it's got all of that point information, but in order to marry them up, it needs to render them. So yeah, now I can see that annotation. And it's red. This does not look clickable in the actual app, pointing at the Ready Workspace row. So it's bringing all of these annotations in and making a punch list. So now we can work through those annotations interactively and address everything that I wrote down. So this basically separates my thought process into 2 passes. I get to be completely offline just with the documents and my pen, and I get to just think about the documents and write notes as they come to me, without acting upon them, just doing that thinking. And then I get to go through a separate pass where now I act upon all of those annotations. So there are the 3 annotated pages. It said 4 at first. I remember. Oh, a 4th mark on page 1 was just a stray pen touch. Ah, okay. That's kind of cool that it figured that out. So sent these 3 annotation pages. Let me know if you'd like to walk through applying these as edits. So let's talk about this user needs a back button. So let's start with number 1. And so I'll often do this with the reMarkable right here so I can read the annotations a little bit better, but I don't happen to have it on me right now. but we did just look through it, so it shouldn't be that difficult to walk through mentally and say, yep, that's the one that we need to talk about. So, and by the way, this kind of work might be, haiku might be sufficient for doing most of this. So, so I do want to optimize this process and make sure that when it's doing something that haiku can handle, then it drops down to the lower model. I think most of the reading text and pulling things and calling APIs, that's all haiku work. I think it's just when we get to the point of talking about what this means and how to apply it, that's when we'll want to jump up to some reasoning. But sonnet level reasoning is perfectly fine. In fact, it probably doesn't even need to be high reasoning or high effort. So, so it's basically re-render the SVG using the Wireloom skill. So yeah, as soon as I installed Wireloom, I made a skill that says this is how you use Wireloom in order to create these annotated wireframes. For example, always use numbers in the callouts and then put the text in the document. Whereas by default, without that skill, it was putting text in the callouts, which made the actual wireframe very small. So yeah, it's not just how to use this tool, it's how to use this tool in this context. And that's what skills are for. So now it's rendered a back button. And so, yeah, basically, in response to that, that annotation right there, it said, I completely understand it. And then let me just do the right thing. And so it regenerated it and checked it. And now let's move on to number 2. So yeah, this is the process of write things down, run it through this process, understand them, update the documentation. This, when done to the extreme, can get you completely outside of the typing a prompt and looking at results, and this can get you now to where you are overseeing the entire operation. So once I've got it completely operationalized, then it'll just be agents that are constantly looking for me to change things on the document, and then say, okay, we need to have this conversation. Oh, I need to update this documentation. Oh, I need to make this code change. I need to, and figure out what needs to happen and just do it. Once I get to the point where I can trust all those pieces because I've measured them, then we will have that full software factory. In the meantime, this is pretty good. So yeah, here it's wanting to go on to number 2 or number 3, and at this point, I think I need to call it. Let's check in on the original task. So okay, it's got some results here. Okay. I have complete precise root cause chain, and it's decisively not a policy distribution bug. Okay, I thought it would be, but it's not. So commit. So the MCP works in a scratch pad, makes a whole bunch of changes, understands what those changes are, and then says, okay, yep, these are good, and then it calls commit. And so that changes the fact types, the specifications, distribution rules, authorization rules, whatever it put into the scratch pad, and creates facts. So it pushes those facts to the replicator when you commit. So commit correctly loads all 3 relevant facts from local storage, and then uses the single use user in order to create the channel owner. Then it calls web client save, and that's what folks at the replicator. The tenant replicator's actual save request only persists 2 of the 3 facts. Interesting. The repro channel owner. Oh, repro reproduction. It's it's created new fact types just for the repro. That's kind of cool. The exact fact for channels for owner, and silently dropped somewhere on the wire during the server-side processing. Interesting. So I wonder if the yeah it's using single use. It should be generating a key pair. I wonder if it faked that in the scratchpad instead of saving those steps in order to do the real thing on the replicator. It should be able to do that in the scratchpad. It's it would have to be able to sign the facts in the scratchpad. I don't think it's got those cryptography primitives in order to do that. So that might be what we were talking about here. Okay, so it looks like I have a reproduction. It looks like I've got a potential resolution to this problem. So I get this problem solved, and then I should be able to create those facts, send them to the replicator, and then run the query and get them back. And then I should be able to go from machine to machine, run those specifications, see those facts in different places. So yeah, basically build an application and then use it inside of any one of my harnesses. It's going to be cool. All right, so next week I will demonstrate that working, and we should be able to get Jan signed up through this user interface we just looked at the designs for, and then he should be able to start using the Jinaga MCP to build applications that help him to do everything that he needs to do. Okay, and then after we've got that all proven out, I will open that up to you, and then I will offer invitations for you to participate in the private beta. So come on back, and let's build this thing together, and I will see you next week.